Hello, this is Tim Olson. In today's video, we're going to look at surface modeling tools, specifically cover surfaces. A cover surface creates a surface from a closed loop of curves. It also includes options for tangencies, guide curves, and bulge factors. In this video, we're going to demonstrate making covers from simple planar curves, n-sided three-dimensional curves, covers with guides, and tangent covers. In our first example, we look at a planar cover surface. We're going to go select our cover surface tool and select the outside boundaries of our planar surface. Note you can also have interior holes, as in this next example, and all the curves that were used to create the cover surface are associative, so you can move and reposition your curves as long as you keep the boundary closed, and your surface will automatically update. Our next example is an n-sided cover using non-planar curves. In this example, we have a collection of lines and arcs that we'd like to cover. So we're going to select the outside curves representing the boundary to create our surface. Internally, your complex shapes are really represented by a four-sided boundary patch with trimmed curves. Let's go ahead and look at the surface definition by turning on the ISO lines, and here you can see the underlying shape of our surface. Let's go ahead and take this surface, and you can see that it is compatible with downstream modeling operations such as thickening. Our next example is a cover surface with guide curves. The guide curves are defining the internal shape from the outside boundaries. Let's go ahead and select all the green curves defining the outside shape, and now the blue curves defining the inside of the shape. Note your guide curves can cross. The only requirement is they must be within the projected shape of the cover surface. Like all other surface curves, you can take these guide curves and move them, and the surface will update. Our next example, our curves are all inside. They're not touching the outer curves. And again, we'll select the green curves representing the outer curves, and then the blue curves, which are all inside the shape. And let's go ahead and select some of those internal curves and move them around. We can get some interesting shape modifications with just modifying the guide curves. And our last example for guide curves is using point entities. And let's go ahead and select all of our outside curves, and then for the inside we'll select 3 point entities. Each of the points then defines a position that the surface is constructed to go through. We're modifying all 3, but you can also go ahead and just modify one individual point. Our final example using the cover with guides curves is comparing the construction of a skin surface and a cover with guide curves of the same set of 3D curves in the construction of a point. Our first example, we created the skin going to a point, and then in our second, we're going to use the cover with guide curves. You can see the skin created a very sharp point, whereas the cover with guides created a very smooth front. If we turn on the resolution for these two, you can see the ISO lines as they demonstrate the difference between the two underlying surfaces. Our next demonstration shows the tangent cover surface. The tangent cover surface lets you reference surface edges such that the resultant surface is tangent to its neighbors. Let's go ahead and tear it out and grab our tangent cover surface tool and start selecting edges. In this case, we have 12 edges of surfaces that will be used to construct our new tangent cover surface. This tool is great for filling holes in your models. Let's go ahead and next examine the surface continuity from our recently created cover surface using the zebra plots. And as we zoom in, we can see that our created cover surface is G1 tangent continuous with its neighbors. In our previous example, we used the cover surface to fill a hole in our model. In this example, we use that same tool as an example to add a cap to a model. So we're going to select this open edge and we're going to cap it. Then I'm going to modify the bulge factor, which will change the resistance to the surface to deform. And the lower the bulge factor, the less resistance it has, and the higher the bulge factor, the more resistant it has to change. So this is a 0.1, and now we're modifying it to a 0.9 value. In our final example, we create a tangent cover surface, only instead of referencing a surface edge, we're going to start off referencing the curve. After we reference our curve, let's go around selecting all of the edges of surfaces to create our cover surface. Again, this is just to show that you can mix your curves with your surface edges to create a tangent cover surface. Let's go ahead and modify that bulge factor, which was 0.9, back down to something more reasonable as 0.2. Thanks for watching. If you would like to have more tips and videos, please visit us at www.masterviacad.com.